Alright, in this series of videos we're looking at different ways of solving quadratic equations, and we've talked about the factoring method, the graphing method. Now I want to talk about completing the square. And the idea of completing the square, you've probably heard of this concept before, but we're going to use it in a bit of a different way here. The whole idea behind how we're going to use it is the idea that if I have a simple quadratic, x squared equals 4, let's say, and I want to know the solutions to that, all I need to do is, if I have a square, I can get my answer by square rooting both sides. And since there's two square roots, remember a plus and a minus, I would get my solutions. Alright? This equation, by the way, I could have solved it by setting it to 0 and using the factoring method. The factoring method was to set it to 0, factor my expression, which in this case is a difference of squares. Two things multiply to 0, which means that each of those would equal to 0. So what would make the first bracket 0? 2 would. And the second bracket 0? Negative 2 would. So I get my two answers. Alright, the power behind completing the square is that it allows us to solve things that are more complicated, specifically things that don't factor. Let's take just a slightly more complicated situation. Let's suppose I had this. Let's put a 3 there. 3 times that squared is equal to 18. Alright? Now, that's a quadratic equation. If I multiplied it out, I have an x squared term. And your first inkling might be to multiply out this expression. But actually, if we were to divide both sides by 3, and then square root both sides, so when I square root a square, that undoes the effect of the square, and I get plus or minus root 6. I get plus or minus on both sides, but since I've got an equal sign, I only need to show it on one side, because the equal sign makes it apply to both. And then if I subtract 2, I get an answer of negative 2 plus or minus root 6, which is really two answers in one. X equals negative 2 plus root 6 is one answer, and the other one is negative 2 minus root 6, which is the other. And these are two irrational numbers, two very ugly decimals, but those values of x would make this equation true. Alright, so let's get to completing the square. The whole idea of what we want is in order to use this method, is some part of our expression to be a square. And for the purposes of what we're doing, most of the time it's going to be a binomial squared that we're going to need to create. And before we get into that, perhaps just a little bit of a refresher on how binomial squares work and their transition into trinomials. If I take a binomial and I multiply that out, remember I square the first, I multiply and double, so I get 6x, and I square the last term to get 9. So this binomial squared is equal to what we call a perfect trinomial square. Okay? So what I'm going to typically need to do is go from this form back to this form, because this is the kind of expression I'm going to need to use the square rooting on both sides to solve my equation. So just again, this is just a refresher. If I had x squared plus 10x, the number I would need here, in order for all three of these terms to factor perfectly into a perfect square, x plus something, we know that these two terms doubled have to give 10. So therefore we know this would have to have been 5, and therefore this would have been 25. Alright, so just a little bit of a refresher on the kind of numbers these have to be to factor perfectly as a binomial squared. Alright, let's use this idea to solve this equation. I have a quadratic equation, and you might look at this and say, well, that one looks like it factors, and indeed it does, to x minus 3, x minus 1 equaling 0, and therefore we can see that x is equal to 3 or 1. So we can solve this equation by factoring. But what we want to do now is learn another method, because we're not always going to have quadratic equations that factor like this one does. So we're going to want to complete the square. Alright, so we're going to focus in on x squared minus 4x. Now, we want this number to be something so that this entire expression factors as a perfect square. Alright, so I'm going to move the 3 to the other side. Again, you've done completing the square in a different context before, so this probably is sounding familiar. And the number that I need in this position, remember, is if I take half of -4, which is -2, and square it, I need 4 in that position. And to keep things in balance, if I add 4, I need to subtract 4. And now this should factor perfectly, and it does, as x minus 2 squared. I have my -4 sitting here still. And then what I'm going to do is I'm going to isolate my square. So I'm going to add 4 to both sides. Now this might look familiar in terms of this is the kind of thing we were doing right at the beginning of the video. I isolated my square. I'm now going to square root both sides. So the square is going to go away, and I'm going to get plus or minus the square root of 1, which is 1. And then I'm going to add 2 to both sides, so I get 2 plus or minus 1. And so my answers are 2 plus 1, which is 3, or 2 minus 1, which is 1, which you'll notice is giving me the same answer as the factoring method did. Okay, so I just solved that equation by completing the square. Alright, well, now where the method of completing the square is more handy is when you have expressions that don't factor, such as this one. If you tried to factor the trinomial, you wouldn't be able to. So it still has solutions, or probably still has solutions, values of x that make it equal to 0, but we need to come up with another way to do this. So we are trying completing the square in this video. So what we're going to do is we're going to start off with our x squared plus 12x, and we need to have a number here that makes that factor perfectly. And whatever number we add, we're going to subtract to keep it in balance. And the spare -1 that's sitting there, we're just going to move it to the other side for now. Positive 1. So the number that will make these first 3 terms factor is half of 12, which is 6. Squared is 36. So if I add and subtract 36, that will make these 3 terms factor perfectly as x plus 6 squared. And then I can add the 36 to the other side in order to isolate my square. I can square root both sides to get plus or minus the square root of 37. Subtract 6, -6, plus or minus root 37. And it's perfectly acceptable to leave your answer like that. Remember that does mean 2 separate answers. That number and that number. Okay, and just because these are kind of obscure numbers, let's just check one of them just to show you that this actually does work. I'm just going to type this number into my calculator. So we have -6 plus the square root of 37. The decimal for that is as shown, and I'm just going to store that, STO button down here on the lower left, store that in my x variable. Okay, so I can simply now type in this to the screen, x squared plus 12x minus 1, and that's supposed to be the value of x, one of them anyway, that gives me a value of 0 when I press enter. It does, so I know that's the correct solution. And similarly, the other solution would work as well. Alright, let's look at one more equation for solving by completing the square. This is a little bit messier. This time I've got a coefficient other than 1 in front of my x squared. So I'm going to need to factor out a 2 out of my first 2 terms, because I'm going to put the 1 on the other side, as I normally do. The constant goes to the other side. So that's going to be x squared plus 8x, and then plus something to make it a perfect square, minus the something to balance it out, and the 1 goes to the other side. Alright, so the magic number here is half of 8, which is 4, squared, which is add 16 minus 16. Alright, the first 3 terms get grouped together in a bracket, x squared plus 8x plus 16. and the term on the end comes out, but it's multiplied by 2 from the front, remember. So 2 times negative 16 is negative 32 out here. And now this factors as x plus 4 squared. And if I add 32 to both sides, that's going to equal 31. Alright, I want to isolate my square, so I need to divide by 2. This is where it's going to get a little messier. I'm going to square root both sides, which is plus or minus root 31 halves, which is root 31 over root 2, and if I multiply top and bottom by root 2 to rationalize the denominator, I get plus or minus the square root of 62 over 2. And then if I bring the 4 to the other side, negative 4 plus or minus root 62 over 2. And it might be nice to have a common denominator, so let's write this as negative 8 over 2 plus root 62 over 2, which is negative 8 plus root 62, plus or minus root 62, all over 2.